Good morning to all. Myself A. Pravalika from the Department of ECE section. Today we are discussing about cross power density spectrum. Definition. Consider consider two random process x of t and y of t. If x of t and y of t are jointly White's and stationary random process, then the cross power density spectrum is defined as the Fourier transform of the cross correlation function of x of t and y of t. It is expressed as xy of omega equals to minus infinity to infinity r xy of tau e power minus j omega tau d tau. By inverse Fourier transform, we can obtain the cross correlation function Rxy of tau equals to 1 by 2 pi integral minus infinity to infinity Sxy of omega e power j omega tau d omega. For two signals x of t and y of t, the cross power density spectrum denoted as Sxy of f is the Fourier transform of the cross correlation function between x of t and y of t. Sxy of f equals to f of Rxy of tau, where Rxy of tau equals to cross correlation between x of t and y of t. F equals to Fourier transform. Properties of cross power density spectrum. Sxy of omega equals to Syx of minus omega equals to S star Yx of omega. Consider the cross correlation function Rxy of tau. The cross power density spectrum Sxy of omega equals to minus infinity to infinity Rxy of tau e of minus j omega tau d tau. Let tau equals to minus tau, then Sxy of tau equals to minus infinity to infinity Rxy of minus tau e power j omega tau d tau. Since Rxy of minus tau equals to Ryx of tau, Sxy of omega equals to minus infinity integral minus infinity to infinity Ryx of tau e power minus j of minus omega tau d tau. Sxy of omega equals to Syx of minus omega equals to S star Yx of omega. Conjugate symmetry. If x of t and y of t are real signals, Sxy of minus f equals to Syx of f, and Sxy of minus f equals to S star xy of f. This means the negative frequency part of the mirror linearity. For signals x1 of t, x2 of t and a constant a, S of ax plus y into x of f equals to as xx of f plus syx of f. This property allows combining spectra of multiple signals. Relationship to auto power spectrum. When both signals are the same, Sxx of f equals to xf of x star f. So CPSD becomes auto power spectral density. Sxy of omega equals to 0. Syx of omega equals to 0. Then if x of t and y of t are orthogonal, from the properties of cross correlation function, we know that the random processes x of t and y of t are said to be orthogonal if and only if their cross correlation function is 0. That is, Rxy of tau equals to Ryx of tau equals to 0. We know that Sxy of omega equals to integral minus infinity to infinity Rxy of tau e power minus j omega tau d tau. Sxy of omega equals to 0 and Syx of omega equals to 0. Sxy of omega equals to f of a into Rxy of t comma t plus tau, and Syx of omega equals to f of a into ryx of t comma t plus tau. Also, if x of t and y of t are jointly WSS random processes, then Sxy of omega equals to f of Rxy of tau and Syx of omega equals to f of Ryx of tau. Xt of omega yt of omega equals to integral minus t to t x of t e power minus j omega t dt and integral minus infinity minus t to t y of t1 of e power minus j omega t1 dt1. We know that Sxy of omega equals to limit t tends to infinity e of x star t of omega yt of omega by 2t, that equals to limit t tends to infinity 1 by 2t e of integral minus t to t x of t into e power minus j omega x dt integral minus t to t y of t1 of e power minus j omega x1 dt1 and limit t tends to infinity 1 by 2t integral minus t to t and integral minus t to t e of x of t into y of t1 of e power minus j omega x e power minus j omega x1 dt dt1. Sxy of omega equals to limit t tends to infinity 1 by 2t integral minus t to t integral minus t to t r xy of t comma t1 into e power minus j omega of t1 minus t into dt into dt1. Let t1 equals to t plus tau. S xy of omega equals to a of integral minus t to t r xy of t comma t plus tau into e power minus j omega t dt equals to integral minus t to t a of r xy of t comma t plus tau into e power minus j omega t tau d tau. Sxy of omega equals to Fourier transform of a of rxy into t comma t plus tau. Sxy of omega equals to integral minus t to t a of rxy of t comma t plus tau into e power minus j omega t omega tau d tau. 1 by 2 pi integral minus infinity to infinity Sxy of omega e power j omega t1 d omega equals to 1 by 2 pi integral minus infinity to infinity integral minus t to t a of r xy of t comma t plus tau into e power minus j omega tau e power minus j omega t1 dt d tau equals to integral minus t to t a of r xx of t comma t plus tau into 1 by 2 pi integral minus infinity to infinity e power j omega into t1 minus t d tau d omega integral minus t to t a of rxy of t comma t1 t plus tau into del of t1 minus tau into d tau. 1 by 2 pi integral minus infinity to infinity Sxx of omega into e power j omega t1 d tau. A of rxx into t comma t plus tau equals to inverse Fourier transform. Similarly, for jointly White's and stationary random process x of t and y of t, we know that a of r xy of t comma t plus tau equals to r xy of tau. Problem. Two signals are given as x of t equals to 5 cos into 2 pi 50t, y of t equals to 10 cos of 2 pi 50t plus pi by 4. Find the cross power density spectrum S xy of f. Find Fourier transform of a cos of 2 pi f naught t plus pi. The Fourier transform is a by 2 e power j pi delta f minus f naught into plus a by 2 e power minus j pi del of f plus f naught. X of t equals to 5 cos of 2 pi 50t. X of f equals 25 del of f minus 50 plus 25 del of f plus 50. Y of t equals to 10 cos of 2 pi ft plus pi by 4. Y of f equals to 210 ej pi by 4 del of f minus 50 plus 210 e minus j pi by 4 del of f plus 50. Y star f equals to 210 e minus j pi by 4 del of f minus 50 plus 210 ej pi by 4 del of f plus 50. Sxy of f equals to 12.5 e power j pi by 4 del of f minus 50 plus 12.5 e power j pi by 4 del of f plus 50. Thank you.